Hello, everyone. Welcome to the Math Magician's Den. This is the Herm Dog. We're going to talk about implicit differentiation. And to talk about implicit differentiation, the first thing we have to do is talk about the difference between explicit form and implicit form. This first equation right here, y minus 2x squared equals 5, you should notice that is not solved for a particular equation or for a particular variable. It's not solved for y. It's not solved for x. This is implicit form. Now, if I were to take that equation and actually solve it for y, I would add the 2x squared to the other side, and I would get y equals 2x squared plus 5. That's explicit form. I've explicitly solved this equation for y. Explicit form. Same thing with the next one. If I have an equation here, x times y equals 1, this is implicit form because it's not solved for x. It's not solved for y. But if I solve for y, I could divide by the x, and I get y equals 1 over x. That's explicit form. Now, what's great about this, these two equations over here, it would be really simple to take the derivative of those. But what am I going to do if I have an equation that looks like this? How do you solve that for y? I can't. So we've got to figure out a way to take derivatives of equations or expressions in that form. And today we're going to stick with expressions. What is the derivative of x cubed with respect to x? Now, if you take this notation, d over dx, that means take the derivative with respect to x, okay? So if I were to take the derivative of y, that's like saying, hey, I'm taking dy dx. If I'm going to take the derivative with respect to x of a function f of x, well, that's going to be the derivative of the function f prime of x. But we're doing it with respect to x. So watch what happens here. If I decide to take the derivative of a couple different expressions, this first one, I think we know the derivative of x cubed. You bring the 3 out front, subtract 1 from the exponent, and there is my derivative, 3x squared. Now, if we take the derivative of y cubed, this is a little bit different. Yes, it's still going to be bring the exponent out front, take your function, raise it to the second power. But here's the thing about this. How do you know that y is not some function of x? If you remember, if you've watched my other videos, even before this, we talked about the chain rule. If you had a function, let's say x to the second plus 1, and you raise that to the third power, to take the derivative, you need to take the derivative of this outside function. So think of this as being your y, okay? So this is basically y cubed. What's the derivative of y cubed? Well, it's 3y squared. You bring the 3 out front, and you take that function, x squared plus 1, and you raise it to the second power now. But here's the thing. The chain rule says that you're supposed to multiply by the derivative of the inside. What's the derivative of the inside here? Well, it's 2x. Well, in the blue, if I called this y, what's the derivative of y? It would be y prime. So down here, when you take the derivative with respect to x of something that involves a y, you have to think of a chain rule. Y could be a function of x. You need to multiply by its derivative, y prime. So take a look at this next one again. The derivative of 2x squared would be 4x using our power rule. And the derivative of 3x would be just 3 because the derivative of x with respect to x is 1. Now, if I take a look at the next problem here, the derivative of 2y to the fourth would be 4y. But for all you know, y could be a function of x. So you have to multiply by the derivative of y prime. The derivative of 3y would be 3 And you'd have to multiply by the derivative of y with respect to x, which would be y prime. Now let me write this another way. This is 4y, and we need to multiply by the derivative of y with respect to x. The derivative of y with respect to x, it would be dy dx. The derivative of 3 times y would be 3 times the derivative of y with respect to x. Now, if I did that same thing over here with this function again, I would take 4x, and if I did the same thing I did over here on the right, I'd have to multiply by the derivative of x with respect to x. But that's just 1. And it's the same thing for the 3x. I would take 3 times the derivative of x with respect to x, which is just 1. So you'll notice over here, I didn't write the dx because they're equal to 1, but over here, I had to write the dy dx's. Let's do a few more here. So let's mix it up a little bit. What's the derivative of 4x to the 5th with respect to x? Well, that is going to be 20x to the 4th. And technically, I'm supposed to multiply by the derivative of the inside with respect to x, dx. The next term, I got to take the 3 and bring it out front, make this 9y to the 2nd, and I have to multiply by the derivative of the inside, which is y with respect to x. Now, obviously, this drops out of the problem because dx is just equal to 1. So my answer is going to be 20x to the 4th plus 9y squared. And the dy dx, I can either leave it as dy dx or I can write it as y prime. There's my derivative for that expression. And again, you'll notice it's a lot quicker on these problems if I say y prime, but it is definitely okay to say dy dx instead. What about sine? What's the derivative of sine? The derivative of sine is cosine of y. But chain rule says you have to multiply by the derivative of y. What is the derivative of y? It's y prime. All we're thinking about here is a chain rule. If it's not x's, if it's anything else, you have to consider the chain rule and multiply by the derivative of the inside. Now let's throw a little bit more in here. What if I gave you a product, x squared times y cubed? Well, we're going to do the same thing we always did with product rule. I'm going to take the derivative of x squared, which is 2x, and technically I'm supposed to multiply by the derivative of x with respect to x. And then that's supposed to be multiplied by the second part, which is y cubed. Product rule is plus. Now I'm going to take x squared and I'm going to multiply by the derivative of the second part, which is 3y squared, but the derivative of y with respect to x, I've got to multiply by that because of the chain rule. Now you notice here when I multiply by the derivative of the inside, it doesn't give me anything. It just gives me 1. So my answer over here is 2x y cubed plus 3x squared y squared times dy dx, or y prime. And I usually write y prime because it's a lot faster. One more problem here. This one involves a quotient rule. I'd have to take the derivative of the top, which is 2x. And what's the derivative of x with respect to x? It's just 1. I need to multiply that by the bottom, which is 3y to the 4th. Quotient rule is minus. The top is x squared, and the derivative of the bottom would be 12y to the 3rd. But what's the derivative of y? With respect to x, it's dy dx. All over the bottom squared, which would be 3y to the 4th squared. Now, if I do some simplifying here, this is just 1. That first term would be 6x y to the 4th minus 12x squared y cubed y prime all over 9y to the 8th. Now, I noticed that if I wanted to, I could reduce here. I could take a 3 out of everything. I can take a y to the 3rd out of everything. And I'm going to be left with 2x minus 4x squared. And sorry, I forgot a y on that first term. Second term is going to be minus 4x squared y prime. And on the bottom, I'm going to be left with 3y to the fifth. So hopefully this implicit differentiation makes sense. I'm going to supply another video later where we talk about implicit differentiation with not just expressions, but with equations and how to actually find slopes of tangent lines. If you like this video, please hit the like button. If you feel like you want to subscribe, hit the subscribe button, and I'll be posting more videos later on.